Hi everyone, welcome to week 5. We're going to cover 3 things. First, we're going to compare data modeling. Then we're going to assess trend analysis. And finally, my favorite topic, explain regression analysis. Thank you. We're going to cover a number of things this week. First, descriptive analytics, data modeling, trend analysis, and finally, regression analysis. So learning objectives are to look at data modeling and make some comparisons. Again, look at trend analysis and finally regression analysis. So here's a couple of comics around descriptive business analytics, and while you're looking at those, as the name implies, you're trying to basically just take data and see what is in it, what's going on, what are the main descriptive characteristics of the data. So here's a chart that shows the difference between kind of looking at descriptive analytics, various views of it, as well as the tools. Let's just talk about descriptive analytics in general. So it looks at the data, analyzes past events, and sees if there's any insights in it. Second, it looks at past performance, understands it, and looks at historical data to look for reasons why things didn't do so well or why they might have done well. And finally, management reporting such as sales and marketing, operations, and all use some kind of post-mortem analysis to try and look at what happened and why. So descriptive analytics, basically you can use Excel to do it. The spreadsheet highlighted towards the middle, upper left, shown here just shows the overall performance by category and the totals, and that's a form of descriptive analytics. And to depict those things graphically is, again, you can do that pretty much with Excel. So it's pretty straightforward. The objectives in the data modeling view is, why are they important? What are some of the basic building blocks? And then how have they evolved? So why are they important? They're important because for both IT and the business user, they're a relatively simple representation, generally in graphical terms, that make it easy for IT and the business to talk. So those are the main benefits of it. Is it facilitates interaction between a designer and an end user. Also, the end users have different views and needs for data, so modeling it helps facilitate that. And the data model is a framework that organizes data for different kinds of users. So here are the basic building blocks. An entity is anything about which data are collected and stored. Another way of looking at an entity is it's something that's known in business terms. Let's say in the automotive industry, for an automotive sales organization, the vehicle is very important, and the vehicle is defined by a set number of data attributes, be it the individual vehicle itself, the wheels, the part numbers, all those things. An attribute is one of the things that is part of the entity. So it's an aspect of it. So the VIN number would be an attribute. A relationship shows an association between entities. It's saying what is the nature of a relationship between two known entities. So, for example, an owner may own several different vehicles, so it's a one-to-many. Dealerships, as related to the number of cars, maybe there's an owner of a set of dealerships that has a number of cars, so it would be many-to-many. And then one-to-one relationship would indicate something that's unique. So for every owner, there may be one owner that frequents one dealership. So the dealership would have entity describing attributes. And then a constraint is that nothing's unlimited. Everything is finite. So that would just be an overlay constraint, a restriction on the data. The models that we're going to look at, it's just 5 of them. Hierarchical, you'll see in a minute, it's very, very self-explanatory. Network, relational, entity relationship, and object-oriented. Those are the 5 that we'll be taking a look at. A hierarchical model basically looks at a logical structure. Some call it an upside-down tree for a data model. Here is a graphical depiction that shows such a hierarchy. So looking at a manufactured product, it's made up of multiple components. So the final assembly is everything put together, and then whatever subdivisions there are that comprise that final product would be listed as components. So let's say it's a 3-component product. So an example might be a toy that has a head, a body, legs, and arms. That's 4 components, but that's what we're trying to represent there. And then if you break that, each of those components down further, there may be sub-assemblies which have parts, and so that's why they call it a hierarchy. Earlier, as the name implies, a hierarchical structure contains levels, or also known as segments. And the higher levels, the highest level is one entity, which is the totality of all the other levels or parts. As was shown in the earlier slide, a product is comprised of 3 components. Each of those components may or may not have sub-assemblies and parts that make it up. So it's a parent-child relationship. The higher level is the parent. Those below it are directly below are the children, and then those children may have children, and so forth. The advantages of this approach is that it's very clear what is being discussed. In a database, it does form the relationships which are needed for a relational database orientation of the attributes. And it also can be in a mainframe base which isn't relational. It allows for programming to define the different levels. Disadvantages are sometimes it's very complex to implement. It's difficult to manage, particularly if the overall entity that you're trying to build a hierarchical model is dynamic. Maybe the subcomponents are basically vary from time to time, and then disconnecting children from parent levels is not easy. It is very structured, so that restricts or constrains dynamic changes to the structure. Next data model that we're going to talk about is a network model. And it's created to represent a complex data relationships more effectively. And this is mainly in the graphical or the view of them. Its network model is more finely aligned with what databases are meant to be represented. Codicil and DBTG are 2 of the groups that have developed the standards for this type of data model. So when you hear the term schema, that is a database term. It's the overall structure of the database itself. Schemas are created by database administrators. A subschema is something that's seen by the application that accesses the data. And then data management language is the tool that's used to query or to create or change records inside that particular database or data model, I should say. So here are some of the technical terms: schema data definition language, again used by the database administrator, enables him or her to be able to define schema components. And then there's sub-schemas, or schemas that are the level below, if you will, like similar to the hierarchical database model. And then basically these things are all managed in the database. So as mentioned, it resembles a hierarchical model. It has a collection of records. It shows a relationship of various levels of, in this case, the lexicon is owner and member. So the owner shows who, basically controls the levels below. Of a network model. It shows things as on the levels, but unlike the hierarchical model, sub-levels can have different relationships with the higher levels, as shown here. So a sales rep, is tied to an invoice. Every invoice that's billed to a customer has a sales rep to it. So there may be many invoices that are assigned to a sales rep. A customer may have many invoices tied to them, and they may have many payments. Of course, you would assume one payment per invoice, and then product itself may have, maybe in different inventories or product lines. So this is slightly different from hierarchical in that it's showing relationships of subordinate levels, but shows that those levels below aren't just tied to a single entity above a parent. It's more of a owner and then a member, as was said earlier. The disadvantages are it is a very cumbersome way of going about things. It doesn't allow a lot of ad hoc query capability. It's very structured, and therefore changes are particularly difficult, can be difficult. And so queries can also be lengthy in duration. The next data model type is relational model, and its genesis was in the 70s. It's very straightforward conceptually, and when it was developed, the computers didn't have a whole lot of power, but today they do have a tremendous amount of power, and therefore the sophistication of these data models can be quite extensive. So you talk about relational database management systems. They have a query language such as SQL. That means that you don't have to have a whole lot of application programming. If you simply know the query language, you can be able to do a lot of things with it. Here you're going to hear about tables, which is similar to the previous discussions of entities, but in this case we're talking about columns and rows of data. Columns represent particular values or attributes, and rows represent various entities that contain those same columns. We'll get to that in just a moment. And of course there's a relational diagram which represents the data model. So so a relational tables, as it says there, it has a collection of related entities, and it's a very logical structure. So here's an example of relational data model. This could be Microsoft Access, it could be Oracle. In it, you have various tables. They're contained within databases, so the database would be the higher level, and then individual tables. Here is depicting an agent, which is defined by 6 attributes, and then their code is what's used to link it to another table. In this case, the customer. The agent code is whoever they're dealing with. So you have all the customer information, and then who the customer code, or the agent code, I should say, is who who they're interacting with. Here's another example. Agent code is used to link, or this is more of a graphical depiction, if you will, of an agent code, the attributes that define an agent, and then the attributes that define a customer, and the linkage is the agent code. The one-to-many, it says one agent may have many, many, many customers, and that's what that diagram means. It's actually the dominant data model that's in place. I mentioned SQL, or structured query language, is a standard regardless of the type of database, relational database, whether it's Oracle or Sybase, whatever, they all use SQL. And so that makes it easier to have resources available that can use various types of data, relational databases, I should say, effectively. The next data modeling type is Entity Relationship Model, or ERD, and it's a little bit newer, and it was introduced by Chen in the mid-70s, so not too long after the relational database model. So, this is based on entity relationship diagrams. It's looking at the occurrence of those entities as a row in a table. And that all makes sense here very shortly. The entity set is a collection of like entities, or things that are business entities that are collected there. And then the connectivity is the type of relationships between those entities. So here's this lends itself very well to graphic depictions. So here it's showing a painter paints many different paintings. So there's kind of a verb context here that's not present in any other data modeling that we've covered till now. So an employee learns many skills. An employee manages a store. So you get the context. This is more like a natural kind of language depiction, but it all reverberates back into the data model itself. Here, graphical ERD diagram, and instead of having a shape for the verb, it's the connecting the connecting object it shows what the both the nature is one to one, one to many, many to many, one to many, or many to one, but it also shows the verb. So the very same thing that we just showed in the previous slide is depicted in a different, this is what's called a crow's foot ERD depiction. So the next type of data modeling is called object-oriented model, or object-oriented design. It's a very, very prevalent method used today. And you'll see there's some analogies between an object and an entity, which we'll show shortly. So an object is described by its content, what makes up the object, similar to attributes made up an entity. But the relationships also are depicted. And so let's move to the next slide. So an object is an abstraction of real world entities. In ERD, those entities had fixed attributes that define them. In object-oriented design, let's say you have multiple systems that you have defined a set object. The attributes based on individual systems can vary a little bit. And so it's a little bit more flexible depending on the source and use of the data. But the idea is that the name of the object, like for example vehicles, is what ties everything all together. So here's a graphical depiction of both object-oriented models and ERD. You'll see on the left an object-oriented data model basically has an entity called invoice which has various attributes assigned to it, but within it is the customer and the product line associated with, obviously, a product that the customer is using. The same thing in an ER model shows a verb. A single customer generates many invoices and has many product lines. So other models that you may hear about are extended relational data models. Again, it was developed because of the complexity of many applications and obviously the diversity as well. And that's just another type you may hear, ERDM. It's also in use today. So in summary, there are, as we went through these very quickly, each model tried to improve on the previous ones, but there are some common characteristics. The whole intent was to simplify discussions between IT and the business and represent real-world things as closely as possible in the IT. This shows the 5 types of models. Object-oriented and extended relational are both examples of semantic data models. And then as we go up the chart, you'll see those are the earlier versions or earlier data models. So the more semantic ones are at the bottom and the least ones are at the top. So basically, each of them is a relatively simple abstraction of what may really be very complex real-world situations. And the common components are entities, attributes, relationships, and constraints. And this is just re-summarizing the different data models. Continuing re-summarizing those things. Okay, the last things that we're going to talk about, one is trend analysis. And what it is basically looking at past data and plotting a pattern to the future so that we may make some degree of prediction. So, for example, in stock forecasting, it's looking at past stock performance and using those patterns to predict the future. So trend, is it a positive or negative trend or no trend at all? And then finally, just looking at regression analysis again. It's a statistical process for estimating a relationship among various variables. So it takes a scatter plot and it fits in a line, basically a line to try and fit the scattered plots as good as well as possible. Y equals AX plus C is a line, but the plot points are statistically analyzed to see what line best fits what's there, a trend line, if you will, against a very, very large scattering of data points. Way of looking at regression analysis is a kind of predictive modeling. It's saying if we have all this past data and it's in data points, then what will the future be? The dependent variable, equals a host of independent variables, and that polynomial basically is used as a predictor for future performance or outcomes. That completes week 5 of our presentation. Thank you for your time and attention.